Hey everyone! Today we're diving into a technology that is absolutely shattering a performance wall that's been holding web developers back for years. Things are about to get a whole lot faster inside your browser. So, here's our game plan. First, we'll look at the problem that developers have been wrestling with for what feels like forever. Then, we'll introduce the solution that's changing everything. After that, we'll explore the incredible new things it makes possible, see how it plays with the tech we already use, and finally, look at how it's completely reimagining what a browser can even be. Okay, let's kick things off with a problem that's probably all too familiar to any web developer out there, hitting that performance wall. You know, that moment you realize you're pushing JavaScript to its absolute limit, and it's just not enough. For years, there's been this performance ceiling. It didn't matter how clever your code was or how much you optimized it. When you got to the really heavy CPU grinding tasks, you just hit a wall. The code simply could not run any faster. So, what's really at the heart of this problem? Well, it's all about how the code runs. You see, JavaScript is interpreted. The browser has to read it line by line and then figure out what to do, which is super flexible, but it adds a lot of overhead. The dream has always been to get closer to native execution, code that speaks the processor's language directly. That's where you get maximum speed, and for years, we've been trying to close that gap. All right, so how do you finally smash through that performance ceiling? Well, the answer arrived in the form of a technology that is, and I'm not exaggerating, truly transformative. And that is WebAssembly, or WASM for short. Now, this is a totally different way of thinking. Instead of shipping JavaScript that the browser has to figure out, you're sending a compact, precompiled binary file. This means developers can write code in languages like C++ or Rust, compile it down into the super optimized set of instructions, and the machine can execute it almost instantly. It is built for one thing and one thing only: pure raw speed. And the results? They're just staggering. I mean, we are not talking about a small 10 or 20% improvement here. WebAssembly can hit performance that is incredibly close to native code. We're talking around 95% in some tests. That is an absolute game changer for what's possible inside a browser tab. So when that performance wall doesn't just get pushed back, but gets completely demolished, what becomes possible? Let's really think about that for a second. What can you actually do with that kind of power sitting right inside your web browser? What new classes of applications can you build when you're not held back by those old limits? I mean, we are talking about entire categories of apps that used to be a total pipe dream on the web. Think about complex, high frame rate 3D games that run butter smooth with no plugin, or real-time video editing happening right on your machine, no server required. Or how about heavy-duty cryptography, or even running machine learning models right there on the device? These are tasks that just crave raw computational power, and now WASM can deliver it. Now here's a really crucial point. This isn't about throwing away everything we've built. This isn't about replacing JavaScript. It's actually about pairing it with something new to create a team that's way more powerful than either one could be on its own. Let's just clear up the biggest misconception about WebAssembly right now, okay? So many people frame this as a competition, like it's WASM versus JavaScript, but that's completely missing the point. The real magic happens when you use them together, playing to the strengths of each. The best way to think about it is like this. JavaScript is the perfect conductor of an orchestra. It's amazing at managing the user interface, handling all the clicks and events, and basically telling all the different parts of your app what to do. WebAssembly, on the other hand, that's your virtuoso soloist. That's the specialist you bring in for the incredibly difficult, performance-critical part of the song that needs pure, unadulterated speed and power. So, when you combine that flexible orchestration from JavaScript with the raw horsepower of WebAssembly, something much bigger starts to happen. The very idea of what a web browser is, well, it starts to change. The browser stops being just a tool for looking at documents and websites. It gets elevated into a true platform, a universal runtime. And all that really means is it's an environment where pretty much any kind of high-performance app can run, delivered instantly to anyone, anywhere. And let me be perfectly clear, this is not some science fiction prediction for the future. For developers who are building high-performance web apps today, this is already the new reality. This is how the next wave of powerful web experiences is being built as we speak. And that leaves us with one last kind of provocative thought to chew on. In a world where your browser can deliver performance that rivals a native application, choosing to ignore WebAssembly, that's not a cautious decision anymore. It's actively choosing to build slower, less capable software. It's basically piling up technical debt that you're just going to have to pay back later. The question really isn't if you should use it anymore. The question is, how are you going to leverage it to build what